Good morning, everyone.
Good morning, sir.
Morning.
Good morning, sir.
Very good morning. Welcome to this online artificial intelligence class number 6. So, what is that we are going to discuss in this class is about the design of artificial intelligence. Most probably today and tomorrow also we will be discussing about this topic. In the earlier classes, what is that we have done is we have discussed about what exactly is artificial intelligence. What are the applications of artificial intelligence? What are the various mechanisms in artificial intelligence? And we also have witnessed a game called as tic-tac-toe game. So this is how I have organized the slides today, because we have a gap of almost 4 to 5 classes. So last class was happened on Thursday. So obviously we need to summarize what actually happened so far. And then I try to give various definitions of artificial intelligence. And the history of artificial intelligence is also needed in the context of your external exams. Then we will conclude the class by discussing something about intelligent systems that we have already discussed in the earlier classes. So if you ask me to summarize what exactly we have done in the earlier classes, we have done this. We have discussed what exactly is artificial intelligence. We can have any number of definitions, like artificial intelligence enables the machine to think. Can we design a system to think like human beings? Artificial intelligence is a mechanism to develop a system which does the tasks of a human being. Can a system can mimic the actions of a human being? The example is artificial intelligence. You have n number of definitions. Can the systems are trying to think like human beings? Can you develop a system which mimic the actions of human beings? Many definitions we have seen on artificial intelligence. So this is what we have been doing for the last 1 week. The end output of artificial intelligence is to generate a predictor. Every time when you develop a classifier in artificial intelligence, what is that we try to do is we try to predict something which will happen at a later stage. Whether it can be a weather forecasting or a stock market prediction or playing a chess game or a tic-tac-toe game, whatever it may be, what is the ultimate aim of artificial intelligence is to predict something. That predicts something we call it as a predictor. So we have also discussed what are the various outcomes of each unit. I said the outcome of learning a subject like artificial intelligence is to develop an expert system. Expert system is a system which takes the expert tasks and it tries to predict something again. So the ultimate aim of artificial intelligence practically is to develop a predictor, and the ultimate aim of artificial intelligence theoretically is to develop an expert system. This is what we have studied in the earlier classes. And we have discussed about various mechanisms of artificial intelligence. The 4 different mechanisms are there. In this class also we'll be discussing about these mechanisms of artificial intelligence with a different name called as, what is that name is an intelligent system. So 4 different mechanisms of AI are there. Can systems think? Can systems think like a human being? Can they act like a human being? Can the systems can think rationally? Can they act rationally? All these are mechanisms of AI. So this third part again we will be discussing today in a different dimension and different context. And we have explicitly discussed the applications of artificial intelligence. While we are discussing about the applications of artificial intelligence, just I try to type something now. So we have discussed about a system called as Deep Blue. Deep Blue is a system which is meant for a chess game. It is a chess playing system that was developed by IBM, and where it has defeated many world champions in this chess. You need to remember the name of the program. The program name is Deep Blue. It was developed by IBM, which has defeated the chess champion Gary Kasparov in 1997 itself. From that time, people try to develop various games, whether it can be a tic-tac-toe game or a chess game or any other nim game or some games. So that's very difficult. Like somebody playing a game, it's very difficult to find what step will be beneficial for him to win that game. Can you develop a strategy to develop a game? That's what the intention of keeping this Deep Blue. We also discussed about an application called as Tesla. Tesla is the name of the company which has utilized deep learning to the utmost. Almost 70 to 80% of the Tesla technology is artificial intelligence, where this Tesla talks about driverless cars, many cars like semi-automated cars. We need to remember that Tesla is the name of the car company, where almost 70% they use deep learning to develop the cars without drivers, self-driven cars, automated cars. This is what we have discussed in the earlier class. We also discussed about something called as a humanoid robot called as Sophia. Sophia is a humanoid robot which can interact with people, which can talk, which can take classes. So all this technology that was behind the Sophia is deep learning. That's what we have discussed in the earlier classes. We have also seen a expert system called as Mycin. It is an expert system pertaining to health informatics, where you give a set of symptoms. It will give the set of diseases that are attributed with these symptoms. It can assist doctors in prescribing medicines. Apart from that, we have almost 256 different features of Mycin. Like when the blood sample was given, it will also predict is there any probability to get cancer or not. Apart from that, we have many other features of Mycin we can discuss at a later stage, because this Mycin is an expert system that will come again in the last unit. So we have also discussed about something called as Hawkeye. Hawkeye is a deep learning mechanism that people use it in a cricket game. It is used to predict the displacement of the ball, the height of the ball after pitching. And we said we have many applications of facial recognition particularly in artificial intelligence, because everywhere, like you see Twitter or Facebook, whatever it may be, whenever we need to process images, generally people will go for this AI. And we have discussed about IBM Watson. We have discussed many other related things. My interest of keeping all this is to create interest to the people who are listening to the class to develop some applications. This is what my intention is. IBM Watson is an expert system which will take questions in natural language and try to answer the queries. IBM Watson is a question and answer mechanism which will process your voice and it will try to answer your question. See, I am suffering with throat pain, and it will ask you what are the other symptoms that you are having. Then it will try to answer your queries by the way. See, it is an innate way of communication. So whether you take a Deep Blue or a Tesla or a Sophia, all systems that we are discussing in the terms of applications we are talking only about prediction. Deep Blue is a program that is meant for playing a game called a chess game. So whenever two people are playing a game, every time there may be three outputs, like A can win or B can win or they can go for a tie. So you have a program called as Deep Blue. Just a minute. We have a program called as Deep Blue, what is the ultimate aim of Deep Blue is to see that every time when you play a game, the computer has to win. So while moving from one state to other state, we need to see that every movement, motion from one state to other state will ensure that your computer has to win. So there is a prediction. In Tesla also, we are talking about car automation. While you are moving from one state to other state, while you are driving, you need to think about the left, right neighbors as well as front and back neighbors. So there is a every time there is a prediction. Sophia, I said Sophia is a humanoid robot which was trying to take a class. So Sophia has to predict. See, somebody has asked a query to Sophia. It needs to process it. It has to predict what actually the next reaction of that person. Mycin, I said, is an expert system which can process your innate data so that it can tell you whether what type of disease you are suffering. So Mycin is an expert system pertaining to prediction. Hawkeye is a system which is going to predict the height of the ball after deviating. After pitching, what is the height? What is the displacement? What is the amount of deviation? All these will change with respect to time. It is the same case in the terms of facial recognition also. We have seen many we have discussed a lot of things, like we also discussed something about weather prediction. So I said we have almost 250 plus different expert systems pertaining to weather. What are the variations of weather? Like I have a statistical data with me, then how can I predict weather based on the dynamic parameters? We have also seen some systems pertain to stock market, because the values of stock market will change with respect to time. If I have the data of the stock market variations for the last 10 years, that is called as a static data. But stock market value changes with respect to the political decisions that people take. Stock market changes with respect to the value, like somebody has invested in a company, your stock value will increase. When you recruit people into the company, your stock value will increase. So your stock market is a dynamic problem to address. We have also discussed about various product sessions. When you go to an Amazon to buy something, based on the way in which you are searching, Amazon can predict. It will train itself and it will predict what is the nature of searching that you are doing, and what is the nature of buying you are doing. Based on that, it can predict this is what you are going to do in the next time. So I also said a lot of applications are pertaining to the way in which you address the COVID also. Like how many people in a company are practicing this social distance mechanism? We have a deep learning system for that. How many people are properly using the masks? We have a deep learning mechanism for that. How many people particularly are using this masks correctly? We have almost 200 plus systems are there. We have deep learning mechanisms to process your x-rays of patients and can predict whether a new x-ray comes, whether this is prone to your COVID or not. All these examples that we are discussing for the last few classes are meant to create some interest in this subject, so that you can also think in this dimension to create some new application in the area of artificial intelligence. When people try to think about the applications of artificial intelligence, generally they try to implement the first phase as implementation of games, or they will try to implement some bots. Because most of the people know this bot, because every time when you go to a banking sector or any e-commerce sector, you have bots that are already installed in your websites. They will interact with people. bots will interact with people, and it will give all the information. So the first way to implement an AI program is whether you can go for implementing a game or whether you can go for implementing a bot. A bot is the easiest mechanism. That's what I said in the last class. If you remember, I said I just spelled a word called as ELISA. ELISA is a bot which will interact with people. At least it will ask 6 questions. Based on the 6 questions, it will tell you the mindset of the people at that moment. That's what we have discussed. So last few classes we are talking about the definitions of artificial intelligence, like how can you develop a program to mimic the activities of a human being, and how can you develop a program to think at least reasonably as a human being. And the outcome of learning this subject is to develop an expert system. But in general, when people try to develop an AI system, they're only trying to build a predictor, because every time AI is going to predict something. We have seen various mechanisms of artificial intelligence. In this class also, these mechanisms of artificial intelligence will come as an intelligent system, because there are 4 different type of intelligent systems. The same way we have 4 different mechanisms. The same discussion will happen today also. This was happened earlier. And the most important emphasis of all the classes that I have taken till date is the applications of artificial intelligence. When we try to discuss about the applications of artificial intelligence, the only outcome I felt in discussing this artificial intelligence is so that these applications will just help you to think in what are the domains of AI where you can apply this AI. And if somebody wish to implement AI programs, the applications are the only mechanisms where you can think about whether you are going to implement a game or a bot. Like ELISA, people call it as a bot, because people now we have some companies like UiPath, Automation Anywhere, or Blue Prism. All people, they are trying to create a bot for everyone. So the outcome of keeping this particular slide in applications is to create some interest in you to develop small applications of AI and just introduce where exactly AI is used. So we also discussed in the earlier classes how can we play a tic-tac-toe game, because tic-tac-toe game implementation will come in Thursday. So we have discussed like 2 players can play this game called as tic-tac-toe. So assume that 2 players are A and B. A can start like this, and B can place, because B has 8 options, you can place B anywhere. Once B plays, A will get the other turn, so A will place here. So there is a chance that A will win here. So obviously B has to be placed here. And even though A has n number of options, A has to be kept here to defer the winning of B. And even B is having n number of options, but B has to be kept here to defer the winning of A. Now after playing B, you have a chance, A has a chance to play. Again, now since A has completed its turn, so B can play now. B has to be kept here to defer the winning of A. And now there is a last chance that was given to A, and A will be placed here. So the outcome of this game at this moment is a tie. So when 2 players play a game, I said you can have A win or B win, or you can go for a tie. 3 outcomes are possible. So the data structure that we have used here is a 3x3 matrix, which has 9 cells, and 3 different values are there. One value is representing a blank, because when nothing was there, we have blanks in this particular 3x3 structure. We have one value of A and we need to have other value of B. So this is what we have discussed in the earlier class. We also discussed because there is I try to create some ambience in the students to implement this game also. That is the reason earlier class I said for a blank you take some value called as 2. For A you take a value called as 3. For B you take a value called as 5. Something we have discussed. But the discussion will again come in the later classes. So that is the reason I'm not emphasizing on this particular thing. So I'm just erasing this entire discussion to go to the next slide. So this is how we have discussed in the earlier classes, and this is what I have typed. So once you are clear with the earlier concepts, now we need to just uh, explore in these questions. Like these questions are very important to answer once you understood the earlier classes. Some of the questions like what is a super A I have not discussed, but when I have shared a document with you in your Google class where it talks about super AI, it talks about modern AI languages and many other questions. Can somebody unmute yourself and tell what are the dynamic parameters? Please actively participate in the class. Please try to unmute yourself and tell me what are dynamic parameters when people are talking about artificial intelligence. Can somebody answer this query?
Parameters that change with time.
What you said is exactly right. When somebody try to build a classifier of artificial intelligence, you must have a statistical data, and this AI system must process some dynamic parameters that will change with respect to time. In weather forecasting, the humidity will change with respect to time. The distance between the earth to the cloud changes with respect to time. Many other parameters will change with respect to time. When you consider stock market prediction, the stock market values for the last 10 years will be static, but the political decisions will change dynamically. The stock, see, the buyers will change dynamically. I invest something in this in the company, your stock value will change. So when people try to think about an AI system, they have to think about statistical data, plus they need to think about dynamic parameters which will change with respect to time. So these dynamic parameters are the only parameters which will give the accuracy of the classifier that was built by either artificial intelligence or machine learning or deep learning. Very important. You process more dynamic parameters, you get more accuracy, you get more robustness, you get more adaptability. This question is very important. So the next question that I have here kept here is, what is the minimum requirement of AI to build a predictor?
Statistical parameters and dynamic parameters.
So what you said is right. You take artificial intelligence or machine learning or deep learning, all these three can work only when you have statistical data. You can have an AI system without dynamic parameters, but you cannot have AI systems without statistical parameters and statistical data. So the main requirement for AI to build a predictor is your database management system. We call the database management system the statistical data, and the parameters that were involved in the statistical data we call it as statistical parameters. The second part is very important, because most of the companies, when they come for campus interview, they will ask you, without data your AI cannot do anything. This is the most important thing. So what is super AI is what the discussion is the question that I have asked. This question answer will be there in your documents that are given in your classroom, Google Classroom.
Super intelligence.
See, systems can think like human beings? Is there any chance that you develop a system that will think exactly as a human being? Is it possible?
No, sir.
No. What you said is right. It's very difficult to predict, develop a system which will think exactly like a human being. What is super is, if a system was developed which thinks beyond the perception of a human being, we call that is a super AI. It's very difficult. A definition is an ideal definition. Like, if can you develop a system which thinks exactly as a human being is wrong. We cannot develop. Super AI is a hypothetical question. Like, can systems think beyond the perception of a human being is wrong. So super AI is can you develop systems which think beyond the perception of human being? It's very difficult to predict, develop a system. Even the definition of AI also, we have no system which will think exactly as human being. That is what a theoretical was. So can we develop a systems which exactly think like a human being? No. Obviously, the answer is no. We can train the systems to partly think like a human being when it was trained and tested. So can somebody unmute yourself and answer, like, what is Sophia?
Sophia is a humanoid robot
Yes.
which
Which
can teach like a human, which can talk like a
Yes.
human.
See, when it can talk, what is the thing that it is doing? What it is processing actually? It is processing your voice. Is it right? So Sophia is a humanoid robot which can take classes for students, which can express itself, which can give facial expressions, which can interact. So when it interacts, it has to process the data and the voice very fastly, and it has to react at real time. So it's very important, like when people talk about either Sophia or Tesla, these two are the prominent applications of AI. So now people, this is also very important in the context, because you are in a state where you cannot live without artificial intelligence. So what are the modern AI languages? Can somebody unmute and answer this query?
Python,
Yes.
Lisp,
Yes.
Java,
Java mostly. Again, go ahead. Java and
Python,
okay, okay.
C++.
See, in the next, I
C++,
understood now. Yes, I understood now. The what will be there in the next slides is, I have kept that some very important definitions of AI, and then we have slides regarding the history of artificial intelligence. Then we have a slide which is telling about the various mechanisms of artificial intelligence. We have already discussed this. See, what are the modern AI languages now? See, when we are doing our BTech in 1997, we have a language called as Lisp. Lisp is a AI language. We have a language called as Prolog. Prolog is an AI language, but all these two are old languages, because we have labs for Lisp as well as Prolog when we are doing our BTech. But now somebody want to represent knowledge, somebody want to represent AI knowledge. We used to take a language called as Prolog. When we need to process AI knowledge and extract something, then we use a language called as Prolog. When we need to process, we go for Lisp. But now what is happening is, the modern AI languages like Python we can call one of the modern AI language. The reason is, whatever activities that we have done in Lisp and Prolog, they can be done very easily using your Python. And modern AI language, you can call Python, as well as R can be partially also called as an AI language, because most of the classifiers that we study in AI or machine learning or deep learning, that will also come in R. And apart from that, you can also call MATLAB also one of the AI language. So Python, MATLAB and R are the prominent AI languages but people, almost 60 to 70% of the people, they go for this Python, because Python is surrounded with a lot of libraries like NumPy, TensorFlow, Keras, PyTorch, Pandas. Many libraries will support this machine learning. So most of the people, if somebody says that Python is an 100% AI language, the answer is yes. And somebody say that 70% of the people use this Python, the answer is yes. So this questions has to be very much clear while going to the next part. The next part, in the next slide, we could see the definitions of artificial intelligence. So we have discussed about this artificial intelligence tries to build a system so that this system output is to mimic like a human being and act like a human being and think like a human being. So this is a standard definition that was there. Yesterday I have almost shared 3 textbooks. One is of Suraj, that is prescribed for your external exams. 2 other textbooks are very important. The names of the textbooks are Rich and Knight, and the other textbook is Navrang. Rich and Knight is a textbook. Most of the people will read this when people go for an exam called as GATE. Peter and Navrang is a very important textbooks when people try to go for research. See, I need to develop an application. I will refer a textbook called as Navrang. When I try to learn AI in the terms of applications and in the context of GATE, I have to go for Rich and Knight. So Rich and Knight is a textbook. Once you read the textbook, the vocabulary in the textbook is very good, so that if you read the textbook, you can read the textbook within 5 to 6 days. If you read every day, if you read 50 pages, obviously that will be completed within 6 days. But initial reading will happen for 1 week or 2 or 3 days. It will take for you to understand the concepts. So 3 textbooks I said. Suraj Arvind is your prescribed text. Rich and Knight is a textbook that will be used for your GATE exam, even for most of the challenging problems in artificial intelligence. Navrang is a textbook where most of the people will use in the terms of research or in the terms of thorough understanding of some concept. So this is what yesterday I have done. So coming to this slide, we have many theoretical definitions of artificial intelligence. It refers to the simulation of human intelligence in machines that are programmed to think like human beings and mimic their actions. This is what the definition that we are discussing for the last few days. We are trying to build a classifier which mimic the human activities, whether it is a thinking or actions. And there is a other important definition, like a system which exhibits intelligence is an AI system. And we have also seen this definition, a system which can solve some NP hard problems is an AI system. These 3 definitions are very simple definitions, but all these 3 are in your textbook and very important definitions. So obviously you can say some system is exhibiting some intelligence. Some existing intelligence means, see, I have asked you to find the shortest path between 10 nodes. So you apply an algorithm called as BFS. It will find all the path, it will explore all the paths and try to give the output. But without exploring all the nodes, can you get the output is intelligence. So intelligence part we will discuss thoroughly in next class, in all the 2 classes, almost probably tomorrow and after tomorrow. We will just try to have an insight on intelligence. So if a system exhibits intelligence, then we call it as an AI system. When a system try to solve NP hard problems, we can say that that system is an AI system. I'm trying to introduce the definitions. We have other 2 important definitions that are given by Rich and Knight and Navrang that will come in the next slides. So these 2 slides, the reason that I kept this is Rich and Knight is the authors for your textbook. Russell and Navrang is the author for your textbook. Yesterday I have shared these 2 textbooks in your Google Classroom as well as email. So you can download and have a look onto this actual introduction and the way in which the authors has written the textbook. Rich and Knight has defined artificial intelligence like this. AI is the study of how to make computers do things at which At this moment, people are doing better. The same thing we are discussing in a different context and different meaning. We are trying to design a system which will mimic the activities of a human being. At this moment, people are doing better. So we need to have a system which can do better than the people at this moment. That's what people are talking in the terms of rich and knight. So Norving, the definition is more research oriented. Can you develop smart programs? So smart meaning is different in the context of artificial intelligence. AI has to do with smart programs, so let's get and write some smart program. This is what the slogan of Peter and Norving. See, the interest of Norving and Russell in coining this smart term is like you have a smart TV. The interest of keeping this particular discussion is, can we integrate artificial intelligence into IoT? Whenever AI is augmented with IoT, then the term will come. The term is a smart TV, smart VCR, smart fridge, smart AC. So we need to have a deep learning mechanism that is augmented with a small IoT technique. Then obviously most of the time people will use this smart. So Norving, the definition will create like how can you design smart programs in AI which will also relate to IoT. So this all these 5 definitions are very important in the context of how do you understand the subject in a different context. But the original meaning of artificial intelligence is how do you design a system which will mimic the actions and thinking of a human being is what it is conveyed in every definition, but these 2 definitions are very important. Peter Norving has created a definition which will give insight, and Richard Knight, the definition gives us what exactly is the target now. The next definition will give you the target of future. So all these 5 we have discussed. So the next slide we have various intelligent mechanisms that we have discussed earlier class also. Before that we also discussed about who has invented this artificial intelligence. We cannot say somebody has invented this artificial intelligence, but somebody like John McCarthy was the person who has coined this term called as artificial intelligence in some conference which was organized in 1956. I'm repeating this again. John McCarthy is a person who has coined this term called as artificial intelligence, and he has implemented and discovered a new language called as Lisp. That is the first step of the history of your AI. The next step of AI will come like how can you make decisions without a significant data? My data is not sufficient. Still, I need to take some decisions based on the even though there is uncertainty in my data. Can you take decisions? That concept we call it as a fuzzy logic. This is the second step of AI. The third step of AI started when people has discovered a language called as Prolog. Prolog is an AI language to represent the knowledge, to extract the inferences. So 3 AI history was there, 3 steps. The first step is John McCarthy has coined this term called as AI in a conference, and he implemented and invented a language called as Lisp. The next step is how people has defined fuzzy logic. How can you take decisions from the incomplete and uncertain data is the second step. The third milestone is people has developed a language called as Prolog that will come in these 3 slides now. John McCarthy was the founder of artificial intelligence discipline. He has coined this term and has invented a language called as Lisp, list-oriented programming language, where most of the terms that we use in Lisp is car and cadder. We just treat everything in the terms of strings and process. You need to remember 2 terms. John McCarthy, and he is coined this artificial intelligence term, and he has invented this Lisp language. The second history, the most important milestone of AI is like Jadesh has invented this fuzzy logic, which has the ability to take decisions in uncertain conditions. So these uncertain conditions will be there in the last unit in the terms of probability. So last unit, like you have a sixth unit where we talk about fuzzy logic and uncertainty in the terms of probability. So the third milestone in artificial intelligence is like Align and Robot has implemented a particularly a language called as Prolog, where most of the people, what is a language? They say Prolog. The reason is we can represent knowledge, we can infer, and we have a lab. I have particularly have a sound knowledge on this Prolog language. So what is the A language till 2006 is Prolog. So three milestones are there. Somebody has coined the term called as AI. That somebody is John McCarthy. He has implemented and invented a language called as Lisp. After this invention, we have an invention called as fuzzy logic, which can take decisions with incomplete and uncertain conditions. That was done by Jadesh, and Prolog was designed by Align and Robot, and we call most of the time Prolog is an A language till the first decade in 2000. So Prolog is a language where you can represent the knowledge as well as process the knowledge and can infer from the knowledge. So these three things you need to remember when you're talking about the history of artificial intelligence. The definition, these 5 definitions are also important because people will ask you the definitions also for a proper understanding of the subject. The next slide, what is that you have is very simple concept, like how many types of different AI mechanisms are there. We are calling that mechanisms now as intelligent systems. This part we have discussed in the earlier classes. It is coming again. The reason is there is a connection between today's class and tomorrow's class. Like tomorrow's class, we discuss about various components of artificial intelligence system. So when you design components, we need to think what components can be designed. So there are 4 different types of intelligent systems. Can we develop systems which exactly think like human beings? It's very difficult. That's what people are telling, and we have discussed and we have seen this in the earlier classes. It's very difficult to develop a system which exactly think like a human being. Thinking cannot be done by a system until unless it is trained and tested. Thinking rationally, can the systems can think rationally is a difficult objective to achieve. So in your textbook says there is a chance that systems can think rationally to the extent of 30% provided you train and test. So it's very difficult to design a system which think rationally in the terms of thinking logically. Thinking rationally is thinking logically. So whatever applications that we have discussed till now, that will come into these 2 parts. Acting humanly. Can you design a system which can act like human beings? This can be developed? Can we design systems which act rationally? Which act rationally can be done? Which assume that there is, can we assume systems which will think logically? By training and testing, this can be done. So acting humanly is 100% achievable, and acting rationally can be achievable, but it depends upon how do you train and test. Rationally is the way in which logically you are thinking. These 4 topics we have discussed detailed in the earlier classes, but the reason that I kept again here is to connect this class with the next class. So in the next class, we are trying to discuss about various components of your AI system. So like, see, what is Sophia? Sophia is an AI system which acts humanly, which acts rationally. To some extent, it can also think rationally because Sophia was trained. Weather prediction system is a system which is acting rationally. Hoka is a prediction system which acts rationally, and to some extent it also thinks. So you need to connect these intelligent systems with your AI applications for a better understanding. So then we need to have some questions to ponder, because every time when you discuss some concepts, even though the scope of these questions was not pertaining to artificial intelligence, but now in this particular time where you are in 2020, we need to understand AI in the terms of machine learning. See, can somebody unmute yourself and can tell me what is machine learning is?
Prediction models.
Yes. Machine learning can be understood something like, how do you extract knowledge from patterns by using some models. These models can be supervised models or unsupervised models. So machine learning, somebody wish to implement artificial intelligence, they have to either go for machine learning or deep learning. So if somebody asks me what is deep learning, I will say a deep learning is a deep neural network. Like indirectly, what is that I can do is, when the data is very less and the number of features are very less, then I will go for machine learning. When the data is more and the number of features are more, then I go for deep learning. This slide is only kept for a future intuition. There is no need that you need to understand this, because you are talking about futures. See, I just asked you from 10 images, what image is pertaining to animal, what image is pertaining to a man. Easily you can have the different futures. But if somebody, like I ask you, in this 10 images, how many are cats and how many are dogs or how many are other animals, then it's very difficult, because cats will have different futures, dogs will have different futures. When the number of futures are more, you need to go for deep learning. That's what I said. So if somebody, see, the understanding that you need to have for this machine learning, deep learning is, machine learning is a mechanism where it extracts knowledge from patterns by using different models. Artificial intelligence is the way in which you enable the machine to think. And if somebody wish to implement AI, they can go for either machine learning or deep learning algorithms. So the last question is very easy, and somebody can answer this. Which libraries of Python support machine learning? Can somebody answer this query? It's very easy and it's very simple. Which libraries of Python will support machine learning?
Pandas,
Yes.
NumPy, Pandas,
Yes. What you said is right. You can have a you can have. See, Python is supported by many libraries called as NumPy, Scikit-learn, TensorFlow, Keras, PyTorch, Pandas, and many more. We have also seen there is another language called as R as well as MATLAB, which will also support machine learning to some extent. Now, if you have any queries, please unmute yourself and ask the queries. So tomorrow's class, we will have a discussion on what are the components of artificial intelligence, and we try to introduce the design of artificial intelligence in a different dimension. In between, even you have any doubts after this class or at any moment, you can contact me, you can send a message, or you can ping me on WhatsApp regarding the way in which you need to develop some applications of artificial. See, I wish to develop some game called as tic-tac-toe game. Can you help me? Something like that you can ask. So if you have any doubts, please unmute yourself and you can interact, because interaction is the most important mechanism that has to be there for every class. See, can you see the message that I have posted in the chat box?
knows